Welcome to the Green Fix Positive Tipping Points special series with guest host Liz Courtney, an award-winning film director and science communicator. This 7-episode weekly special is offering a fresh lens on the climate conversation. We'll explore the science of solutions, the many sparks of change already underway, and the moments when small shifts create big impacts. Expect good news stories, evidence of real progress, insights on the urgency of acceleration, and above all, a huge dose of optimism about the world we can build together. Enjoy the show! Welcome to the Green Fix Positive Tipping Points. Today we are going to be your hosts. My name is Loretta Gutierrez.
I'm Liz Courtney. And for this episode on the Green Fix's Positive Tipping Point series, we're joined by Professor Peter Cox and Professor Carlos Nobre. It is my great honour to introduce Professor Peter Cox, a world-leading climate scientist and Professor of Climate Science Dynamics at the University of Exeter, where he has also served as the Director of the Global Systems Institute. He is internationally recognised for pioneering research into interactions between the land biosphere and climate change, especially on how changes in vegetation and the carbon cycle interact with global warming. Professor Cox led the development of the climate models to understand the potential dieback of the Amazon rainforest under climate change. He is a lead author for the 4th, 5th and 6th assessment reports of the Intergovernment Panel on Climate Change, known as the IPCC, and has been recognised as a highly cited author in global warming research. Professor Cox's career has also included leadership roles at the Met Office, Hadley Centre, and the Centre for Ecology and Hydrology, alongside advisory work for both the UK government and international panels. In 2025, he was appointed the Commander of the Order of the British Empire for his services to science and climate modelling. Congratulations, Peter, and it's wonderful to have you on board.
Thank you very much, Liz.
And I'd like to introduce you to Professor Carlos Nobre. He's a renowned Brazilian Earth system scientist and a meteorologist, recognized globally for his pioneering research into the impacts of deforestation and climate change in the Amazon. He holds a PhD in meteorology from MIT and has spent more than 35 years at the Brazilian National Institute for Space Research, where he helped found the key research centers focusing on weather prediction, Earth system science, and disaster monitoring. Professor Nobre has been instrumental in shaping major scientific initiatives such as the large-scale biosphere-atmosphere experiment in Amazonia and currently serves as the senior scientist at the University of São Paulo's Institute for Advanced Studies. He leads Amazonia 4.0 project advocating for a sustainable, science-based Amazon bioeconomy and is co-chair of the Science Panel for the Amazon. Professor Carlos Nobre, welcome to the Green Fix.
Thank you very much.
So thank you for both joining us today, Peter from the UK and Carlos in New York for Climate Week. It's amazing to have everybody here together at the same time. I think we're going to start by just diving back a little bit to understand the Amazon tipping point, some science and projections around it. And Peter, you were among the first to model the Amazon rainforest reaching a climate tipping point. Can you explain for the listeners that theory and the scientific reasoning that led you to that?
Yeah, for a long time, climate models had assumed things like atmospheric carbon dioxide would go up, sort of assuming that the biosphere, the land, for example, forests, would take up carbon as they have been doing. And of course, we know empirically from observations that that's not true, that the biosphere and land carbon uptake particularly depends on the climate. So we were the first people to do this with interactive vegetation and carbon cycle, to basically say we should have vegetation modelled and soil modelled within the climate model. And we were doing it primarily to see whether there was going to be an impact on the rate of growth of atmospheric CO2 and climate change, because climate change itself would suppress the ability of the land to take up carbon. We were very surprised to find that, well, although that was true and very significant, that the most significant region was the Amazon. In this model, the Amazon, and this was without direct deforestation from humans, just died back under climate change, quite alarmingly. And we discussed that in that Tipping Points program, and that we've done many studies on it subsequently. So that was really what got us interested in this. We didn't set out to look particularly at the resilience of the Amazon rainforest, but it emerged from this study.
And from that study, how have those projections evolved with other new evidence that may be also influencing and providing more insights?
I think it's fair to say that model had the largest impact on the Amazon rainforest of any models. Subsequent models have had less impact, but almost all of them find climate change to be detrimental to the Amazon rainforest in various ways. What's happened subsequently is we've had and Carlos has been key with this, is the recognition that the combination of deforestation and climate change was really quite damaging. Climate change on its own might be okay for a while because carbon dioxide partly protects the forest from climate change, but the combination of the two is a real worry.
Carlos, if I can throw it to you, I know you have a lot of experience with drought cycles in the Amazon. Can you tell us about the experience that you have and what is the impact of warming oceans and shifting rainfall patterns on these drought cycles?
Yes, let me just say I'm also, like Peter, working for many, many decades about the tipping points. In fact, I was one of the first scientists to publish uh, two articles in Science and Journal of Climate, 1990, 1991, 35 years ago. But at that time, uh, we are not really looking much at the global warming. We are just looking at deforestation because in the 1980s, high deforestation rates. So we did a study what would happen with the Amazon if we had a lot of deforestation. And then that initial articles show that the tipping points with lots of deforestation, then 50% of the Amazon would degrade. And then with my PhD student, we did studies saying if we did not have any global warming, only deforestation, then we got this threshold to be 40% deforestation would make the Amazon cross the tipping point. And then another study was if we had zero deforestation, only global warming, and then we got to 3.5. Also, Peter worked a lot with that. 3.5 degrees warming would also make the Amazon cross the tipping point. And then a more recent study, almost 10 years ago, it put together in a land and atmospheric model, ocean model as well. We put together deforestation and global warming. And then that model show if deforestation exceeds 25% and global warming reaches 2 degrees, we could lose even 70% of the Amazon forest. So those are modeling studies. But of course, as you mentioned, we've been involved in the largest scale biosphere atmosphere experiment in the Amazon for 26 years now. And this experiment put a large number of measurements on towers in pastures in the Amazon. So we know now that warming is inducing record-breaking droughts, 2005, 2010, 2015, 16, and the record-breaking drought 2023-24. And this is very much associated with the increase in the Pacific Ocean temperature associated with El Nino, but also, as we know, record-breaking tropical North Atlantic temperature warming. So those two oceans, very warm, they induce this record-breaking drought to 2023, 2024. So therefore, what all these models and the observations are showing, yes, global warming, the oceans becoming warmer, they will induce very severe droughts in the Amazon.
Another impact that was quite interesting, and I know, Peter, you looked at this, was what the impacts of extreme weather could be in an area where you have already had some fallen big trees where the canopy has started to come open. And then you have extreme fires that can start just from a lightning strike. Could you just share a bit more about those runaway fires and how the Amazon can be weakened?
This is something that Carlos told me about once many, many years ago and explained this to me when we were walking across the savannas. Essentially, the transition from a forest to a savanna is mediated often by fire. So if the dry season gets long enough, you have frequent enough fires that the forest can never get fully back in. So you have a tipping point that's mediated by fire frequency. And you can see that very clearly. Carlos showed me a region where you went from a forest area to the savanna area. And we expect that to become more common because of the phenomena that Carlos was talking about with regard to sea surface temperature warmings and both weaker wet seasons and longer dry seasons with the Atlantic. So that's the big issue. And that's probably the mechanism that would lead to dieback in general, is that things get dry and therefore you get more fires and then you stop having a forest and you have a very open canopy, as you said, Liz, that we saw in that experiment.
You have both expertly explained the modeling behind reaching these tipping points. How close are we now to these irreversible tipping points, and what does this mean for the planet?
Yeah, so we don't know exactly. I mean, we've got estimates and we have concerns. What we do know is that the Amazon rainforest has many impacts on the global climate. So, for example, it stores somewhere between 120 and 200 billion tons of carbon, and that's equivalent to 12 to 20 years of current human emissions. So if that was all released, we'd get another quarter of a degree to 0.4 degrees of warming. Maybe more importantly, the Amazon forest evaporates and recycles a huge amount of water through the deep-rooted trees and returns it to the atmosphere, something like 20 billion tons of water per day. And that cools as well, because evaporation cools the climate and it produces clouds that cools the climate. So the net effect probably of the Amazon forest is probably somewhere between a third and 2/3 of a degree cooling of the climate. And if you lost it, you'd lose that, which would mean if we lost, basically burst through not 1.5, but 2 degrees of global warming, most likely. So there's huge impacts, of course, globally, but of course, maybe even more importantly, it's one of the most diverse ecosystems on Earth. It supports millions of people. It would be catastrophic if it was lost or it became unstable.
Just want also to uh, complement a little bit the question by Liz about fires. As Peter explained, the risks of droughts and the desalinization, etc. But we have had for many years a big problem, which is the fires. Very small number of fires were natural cause, lightning strike ignited fires. Last year, 2023 and 2024, we had a record-breaking number of fires in the Amazon. 95% of the fires were man-made. Of course, because it was a record-breaking drought and also a record-breaking heat wave, the fires spread a lot. So they caused 160,000 square kilometers of degraded land due to fires. So basically, in addition to the climate drivers of the tipping points, but now people are really putting a lot of fires. So it will degrade the forest much, much faster. As Peter said, the forest recycles water so efficiently. 20-40% of all the rainfall in the Amazon depends on this recycling. And when you degrade the forest, you recycle much, much less. So this is a point I would like really to make. Fortunately, it seems in the last 3 months, there was a reduction in the number of fires in the Amazon. It seems that the Amazonian countries now are combating the fires because, fortunately, since 2023, very important reduction of deforestation. For instance, comparing to 2022, now we have more than 60% reduction of deforestation. However, degraded forest due to fire exploded last year. And now, in the last 3 months, all countries are being able to reduce the man-made fires. So I think this is very important to combat. And also, a very challenging issue is that most of the fires is not only farmers, cattle ranchers. Last year, most of the fires were by organized crime. Organized crime, for many, many decades, they were doing land grabbing, deforestation, making livestock, cattle ranches, etc., creating an illegal market for these cattle ranches, all those things. But then because of reduction of deforestation in the last 2.5 years, they started using fire to do deforestation. For the first time, we measure in the Brazilian Amazon, the month of May, 51% of deforestation was caused by fires, not man-made deforestation. So many fires that they completely kill all trees. So I'm just saying, tremendous risk of combating organized crime. Organized crime is land grabbing, illegal gold mining, wildlife trafficking, and also drug trafficking. So they are very powerful. Studies show they produce $250, $300 billion a year, and they have a tremendous political power as well. So we have to combat organized crime because this man-made, not only deforestation, but fire setting puts the Amazon at the edge of this tipping point.
When we talk about the edge of that tipping point, it was amazing to travel with you both or to Kashwana, the research center. A lot of people think about research being in labs and sometimes on ships, but maybe you could just paint a picture of what this research center is like in the Amazon.
It's an extraordinary place, Liz, isn't it? I mean, it's so intense in terms of human um, efforts to maintain, in the sense that it has essentially polythene sheets stops most of the water getting through to the roots and to the soil. And so basically it's an experiment to say what happens if you cut the rainfall by a significant fraction to the forest. And it's quite a remarkable place to walk through. And I should have been there many times. And what they found there was really that it took a while for the droughts to have an impact. And then the tallest trees went first. So the big trees they were the ones that suffered most from the drought because it's actually harder to get water up high in the trees. And we've looked at that subsequently. How long it takes depends on how extreme the drought is and also how deep the roots go, the sort of rooting depth. You may remember lowering me into a pit, which was horrific for me, that had been dug out by an amazing Brazilian scientist. And you remember putting me in that pit and I was trying to work out whether I could see any roots. I remember going down there and thinking, I cannot see any roots down here. People were telling me it's going to be fine, the roots are going deep, but they weren't actually. I mean, we went to another site and they were deeper. But things like that are rather critically important, is how resilient the forest is to droughts and how long depends a bit on how deep the roots are. Simple things like that, which can be measured and were measured in that case. So it's a remarkable place, and we're still using data from that, Liz. The project still goes on, and it's remarkably useful because we fear the sort of droughts that Carlos was talking about, and we try to model their impact, but we need to check our models against data. And things like how deep the roots go, how plants respond, how the tubes, the xylem in trees breaks or doesn't break under water stress are absolutely key. So still lots to get out of that data, but it was exciting and scary to go down that pit.
And just to paint a picture for the listeners, it was nearly the size of a big soccer field, and it was the Amazon with a roof over it. And I know that, Carlos, you have so many people looking after that project. When it breaks, to paint a picture, it takes at least 3 days to get there by boat. It was a long way in, right?
Yeah. Yeah. It was an adventure.
Just to complement what Peter said, now, this ecological evolution of the Amazon forest is something unique in the sense that over millions of years, a larger number of trees have very deep rooting systems, 7 to 10 to 12 meters. And the equatorial Amazon forest, most of the Amazon, it was hard even to believe before we did all those measurements. Peter was a leader in those measurements. The Amazon forest transpires more water during the dry season. Can you believe that? Dry season. And because of that, 4 to 4.5 liters per square meter per day. And because of that, the dry season is short and there is rain during the dry season. So it's a fantastic ecological evolution, millions and millions of years. But as Peter and myself, we are saying, the Amazon is so close to the tipping point that we need nature-based solutions. The first one is zero deforestation, degradation, fire. Fortunately, this we are seeing for the first time now in 2025, in the last 3 months, a reduction of fires, reduction of deforestation. And we need really, because all of the southern Amazon, the dry season is 4 or 5 weeks lengthier in 45 years. So we need immediately stop deforestation, degradation, fire, and then immediately do a large scale forest restoration in these degraded areas. The Science Panel for the Amazon, we launched at COP27, the arcs of restoration. There are 2 arcs of deforestation in the Amazon, southern Amazon, Atlantic to Bolivia. This is 2.5 million square kilometers. And then along the Amazonian Andes, Colombia, Ecuador, and Peru, also highly deforested. And that's the area with the largest biodiversity in the world. The Amazon has the largest biodiversity, and that's the area with the largest biodiversity. And then, fortunately, Brazil launched the Arc of Restoration project during COP28 in Dubai. So Brazil is planning to restore a minimum of 240,000 square kilometers all over the southern Amazon. It's from now to 2050, 60,000 from now to 2030, has started this project looking for funding, estimating $40 billion to do it. And also it's donating now uh, money for indigenous territories, other local communities, Afro-descendant, riverine communities to do restoration as well. Of course, in the indigenous territories, only 3% has been deforested. And then giving to cattle ranchers, farmers alone, only 1% interest rate a year to make these people really to move towards a larger scale forest restoration. We have close to 1 million square kilometers in the Amazon, fully deforested, and 1.5 million square kilometers, the several stages of degradation. So we really have to see ways to do large scale forest restoration. We have really to restore in the southern Amazon more than 50% of degraded deforested areas. So this is a big challenge, but I'm hopeful that now with this project in Brazil and also some other Amazonian countries are also starting forest restoration, because it's not only important to remove a large amount, billions and billions of tons of carbon dioxide, it will do it. But the very important aspect is that they will maintain lower temperature compared to today's temperature, and also recycle, as Peter said, recycle water so efficiently, they will avoid the dry season to becoming lengthier and lengthier, because, as Peter said, the dry season reaches 6 months. This is the climate envelope of the tropical savanna. Impossible to maintain the Amazon forest. So yes, forest restoration, essential to save the Amazon.
It's wonderful to hear about the project that you're undertaking, and sometimes people don't always realize that tropical rainforests aren't resilient quickly. My understanding is that if we have an increase in 1.5, 2, or even 3 degrees in the next 100 years, that's at such a speed. Can the Amazon rainforest, can it adapt to that? Can biodiversity change that quickly? I'd love to hear both of your comments on that, so we really understand what's at stake.
So what Carlos suggests here makes a lot of sense, but it would need to be coupled with a reduction in climate change and include the global warming metric, because we are both concerned that some of that replanted forest might not be resilient to climate change if that's not the case. It has to be part of a spectrum, a collective number of measures, I think, Liz, that also deal with fossil fuel emissions as well as restoring the Amazon, or else it won't work out. Oftentimes, we're going to need to do many things here. This is a really tough problem. We're going to need to deal with fossil emissions, whatever happens, and the developed world in particular is responsible for those. We can restore forests as well and stop deforestation, which is the saddest thing of all, isn't it, really, where you're deforesting mature forests. For many years, tropical deforestation was about 20% of global CO2 emissions, probably more like 10% now. Occasionally gets to 15%. Let's stop chopping down forests, mature forests, you would say quite a lot. In the context also, as you're saying, Liz, of controlling climate change by other measures as well.
Yes, for sure, for sure. If we continue with global warming, unfortunately, thousands of scientists are trying to explain, Peter is also working on that, why we got 21 months with the global warming 1.5 degrees, 2023, 24, and up to April 2025. Now we are 1.3 degrees warmer. If we exceed 2 degrees global warming, it will be very difficult to save the Amazon. Very, very, very difficult to save the Amazon. And also some studies that we did show even, for instance, if we exceed 2 degrees and then we lose the Amazon, there is the savannization of the Amazon. The savannization of the Amazon will also increase the temperature 2, 3 degrees. So if we exceed 2 degrees, we are going to get 2100, 4, 5 degrees warmer in the Amazon, because also global warming and savannization. And that temperature makes all of that area in the world inhabitable. 4 or 5 degrees, our body will not be able to lose heat. A lot of places in the world will become inhabitable, even mid latitudes during summer days. But I'm just saying global warming and the savanization of the Amazon will make almost all Amazon inhabitable. And also another tremendous risk of forest degradation all over all tropical forests in the planet is the risks of epidemics and pandemics. Science in the Amazon has already detected 48 zoonoses, virus that can become epidemics and even pandemics. And for the first time ever in 500 years, two of those virus became epidemics in the Amazon last year. One is called Mayaro fever, which is mostly in the Amazon, and the Oropushi fever. This is spread all over Brazil, more than 25,000 cases already. The symptoms are like dengue, chikungunya. It's not like, COVID-19. It's not as bad as killing people, but it's very bad epidemics. Tremendous risk even of becoming pandemics. So this is another tremendous risk of the forest degradation, all tropical forests, but particularly the Amazon.
Over the next couple of weeks, next 2 months, there's going to be a lot of focus coming onto the Amazon and a lot of focus as we lead into COP30. What sort of programs are you planning, Carlos, around the Amazon? And will you be bringing into that indigenous knowledge with cutting edge climate science? Can we expect to see the combination of those two things at COP30?
Yes, for sure. In fact, we finished a study showing that we are going to launch at COP30 that Brazil can, in fact, get to so-called net zero greenhouse gas emissions by 2040, not by 2050 as the Paris Agreement COP26. In doing that, as Peter mentioned, in Brazil, land use change uh, is responsible for 40 to 50% of emissions. So we are showing Brazil really can get to zero deforestation, degradation fires by 2030, and then transition towards renewable energy, and also reducing the emissions by livestock, mostly ruminants. They burp methane a lot. And of course, this is not only true for Brazil. COP30, we have really to be optimistic that unlike the last three COPs, it's like COP26 in Glasgow, Scotland. Most countries, of course, US is out, but all other countries, large emitters, China, also India, Russia, European countries, Brazil, Indonesia. So those countries will really agree on reducing emissions very, very rapidly. And a very important element, we are inviting a lot of indigenous people from not only from the Amazon, from all countries. I attended the Biodiversity COP16 in Cali, Colombia, and I was very impressed the large number of indigenous leaders there because it was related to biodiversity. So this is a very important element of COP30. It will be probably the first out of 30 climate COPs that will bring the indigenous people and being in the Amazon, showing the importance of protecting biodiversity. Let me also say, we for the first time are creating a science pavilion. It's called Planetary Science Pavilion for the first time in 30 COPs. So we are going to bring all the positive tipping points. We are looking for nature-based solutions, but also we are going to bring to the Science Pavilion a lot of indigenous scientists as well. So bringing indigenous people to this COP will be certainly very important.
That sounds wonderful.
As we're drawing the episode to a close, I'd love to ask you in this critical time, what do you think the international community, and in particular, when we refer to high emission nations, what should they be doing or what can they be doing to support the Amazon restoration as part of climate justice?
As Peter said, it's not only land use change, it's global warming. We really cannot let the global warming exceed 2 degrees at all. Of course, all countries have to reduce emissions. Today, China is number one, US number two, India number three, Russia number four, European countries as well, and Indonesia, Brazil. Coincidentally, beginning of this month, I spent 8 days in China, and I gave many talks at university and in development banks, the new development bank, the Asian Infrastructure Investment Development Bank. In my speech, I said China has to take the leadership. US for 4 years is out. So China, please take the leadership. China is the country doing a very rapid energy transition, but it has to accelerate much more. It's very clear. I mean, we have really to accelerate the reduction because science is showing that we may reach 1.5 degrees with the next 5 to 10 years. And if we reach 1.5 degrees by 20, let's say 2035, we will exceed 2 degrees by 2050. So we cannot really allow that. All countries have to accelerate the reductions of emissions.
So, Peter, is someone who's spent decades modeling the potential loss of places like the Amazon, how do you remain optimistic? And, are there positive tipping points that are really helping to turn the tide?
Um, it's a really interesting problem to study, first of all, as a scientist. I think the positive tipping point thing is something we've begun to work on a lot at Exeter, this idea that the sort of non-linearities of tipping points that we worry about with the Amazon rainforest, they also occur in the other direction with human systems and with public opinion and with innovation and with the way people respond to each other. The human realm, from economies to societies to action, is very prone to tipping points, which can be positive. So the sort of thing that's going on at the moment, which can depress you, is this whole Trump denial of the climate science. I think what it might do is to steel the rest of us that are still being thinking sensibly to do more and to work harder. And that's my hope. And then there is a phenomenon, as you know, in networks of people that you can get a tipping point, a bit like Carlos talks about with the Amazon rainforest. You get 40% of people, or sometimes 25%, depending on the network of people believing something. They can tip the rest. And we are close to that, I think, with climate change. And some of the things just make economic sense. Even if you didn't care about saving the planet and avoiding fossil fuel usage, if you wanted to generate energy now in most parts of the world, you wouldn't do it with fossil fuels. You would do it through renewables, very likely solar energy. So I think we're close to the tipping point also for adoption of renewable energy. It just takes a while. And there are always going to be actors in the world that would rather we didn't change because they benefit from us staying the same. But we're close. And I think if we can just tune out the noise, which is completely deliberately misleading, then I think we can continue to do this. And at some point, we'll start to see the CO2 start to come down, maybe in the next few years.
Thank you for a dose of optimism. And Carlos, do you have a dose of optimism for us as well?
Well, I have to have optimism about the Amazon. Globally, I'm very concerned, and I wish Peter also would make some comments because they are studying these social drivers of tipping points. But now I consider a social political tipping point. Why all over the world democracies are electing populist politicians? US, Argentina, Japan, European countries. I'm very concerned because, we scientists have been saying all of these risks of climate change, all tipping points for 30, 40 years. Instead of the population being concerned, and do not elect a president like in this country, US, completely denier in his discourse at the United Nations. He says, climate change is a coup. There is no need to renewable energy, and renewable energy is much more expensive than fossil fuel energy. This is completely nonsense. And this is not happening only here. So, I think there is a risk of social political tipping point. And Peter was saying something very important, how we also in science communicate that to all global population, educate young people, students. So I think that's a big challenge as well.
I think it is. And just to add to that, I think the concern about leadership is there's been a problem for a long time, and it's most of it's now. But there comes a point when we can do it without requiring our leaders to tell us it's true. And we're there now. And most of us know what Trump is saying at the moment is absolute nonsense, as you say, Carlos. So we just don't have to listen to it. We can carry on with what we're doing. And I think there are enough people that want to do this and understand that we can do it, regardless of what our leaders might suggest. They have to follow us in the end if they want to get voted in.
Well, I want to thank you both for a really wonderful interview. Before we wrap up the episode, I'm going to give you one go at the magic wand each. And I'd love to ask you, if you look towards 2035 and you had to change one thing and you can just wave the magic wand and get it done, what would you do?
I would like to see an end to the use of fossil fuels before 2035. We should have done it a while ago, and we're in a position to do it. I think it's almost a question of the historical baggage and the vested interests that stop that happening. But if we could do that, we'd get there. If we don't reduce fossil fuels, we've got to absorb the carbon by other means or do something else radical. So that's the way I would like to see.
In addition to exactly, getting to almost zero fossil fuels by 2035, I also think it's very important for us globally in the Amazon, especially to get zero deforestation, degradation, there's large scale forest restoration, and then a big challenge. Let's start a new bioeconomy based on the social biodiversity. The Europeans came 500 years ago to the Americas and completely ignore the knowledge of all indigenous people. The indigenous people in the Amazon arrived 14,000 years ago, used 2,300 products, almost 300 fruits, 1,500 medicinal plants. So now this is also a big challenge we are doing in the Amazon. Let's create this we call social bioeconomy of standing forests and flowing rivers. And also, of course, everybody likes to eat meat. Let's also move globally, but certainly in the Amazon, to the so-called regenerative livestock, much more productive beef production, but not using no new areas. So that's, I would say, in addition to getting to zero use of fossil fuels, but also zero deforestation all over the planet.
Wonderful. A wonderful use of the magic wand. Again, I want to say thank you both for joining us today in what is a very busy time. Thank you for your work and thank you for sharing all of your knowledge with us today.
It's been very exciting to have you both on. I also want to say to Carlos, we wish you all the best with COP30 coming up in Belem. We'll be thinking of you, and we just can't wait to hear very positive outcomes from that as the world moves forward. So thank you for holding the light on that, and thank you. It's been very exciting to have you here today.
It's been a pleasure.
Thank you.
Thank you.
Thank you very much.